let's take a question in this video. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brake in such that the velocity of the bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of the bicycle in both the cases. Okay, as usual, first thing that we'll do is we will take everything from the question. We shouldn't even miss a single detail. Okay, so let's highlight all of the points that we need. Okay, he attains a velocity of 6 meters per second. He attains, what does that mean? That means by the time 30 seconds is over, he gains velocity of 6 meters per second. Then he applies brake such that velocity comes down to 4 meters per second in the next 5 seconds. Okay, meaning when it says comes down to, that means by the end of the next 5 seconds, the velocity is 4 meters per second. We have to calculate the acceleration in both the cases. Okay, so let's take the data part by part. We'll take the first part as part A. Here they've given that the velocity comes up to 6 meters per second in 30 seconds. The next part as part B, okay, here they're saying that the velocity comes down to 4 meters per second by the end of 5 seconds. Okay, let's take this as the time span. Okay, and you've got Rahul, he starts from a stationary position and the time span that we take over here is 30 seconds. What happens in this 30 seconds? He starts from a stationary position and he attains a velocity of 6 meters per second. Okay, then he applies a brake, right? When he applies brake, in the next 5 seconds, the velocity becomes 4 meters per second. Okay, now this is our entire problem. What we'll do is we will take it as part A and part B and we'll deal with it separately. Okay, first we'll take part A. Part A, where the velocity comes up to 6 meters per second, time is in 30 seconds. We'll take the formulae of acceleration because that's what we have to find. Acceleration is final minus initial velocity by time. Now let's look at all the terms in this formula. You've got final velocity, you've got initial velocity, and you have time. Time we already know is 30 seconds. That is the span of time. Okay, now we also know that by the end of that 30 seconds, by the end of that time span, Rahul has gotten a velocity of 6 meters per second. So when I'm saying by the end of, he has gotten, he has attained, he has gained, when I use words like that, I'm saying that it is the final velocity that they have given you in different words. Okay. So final velocity is 6 meters per second and it is denoted as small v. Now we know that he started from a stationary position, right? So by that I mean he was absolutely still when he started. So at the time span starting, he's doing nothing, correct? So that means velocity is 0. So since he starts with a 0, initial velocity equals u is equal to 0 meter per second. Okay. Time we know is t as 30 seconds. So let's put everything together. 6 minus 0 by 30, which is 6 by 30, which is 1 by 5. Acceleration therefore is 0.2 meter per second square. Right? So let's conclude this first part quickly. In the first case, acceleration is 0.2 meter per second square. Right? Now let's move on to part B. What is all of the details that they've given here? He says that the velocity becomes 4 meter per second by the end of 5 seconds. When I'm using words like this, you already know what you have to do, right? So you have the formula for acceleration, final minus initial velocity by time. Now here in this case, he already is in motion at the beginning of that 5 seconds, correct? And they've already given you that the velocity in the previous case was 6 meter per second. So that actually becomes your initial velocity in this case. You got that? At the end of 5 seconds, it comes down to 4 meter per second. Comes down to 4 seconds means comes down from what? From the previous velocity. And they've given you previous velocity as 6 meter per second. Correct? So then initial velocity is taken as 6 meter per second and we have time as 5 seconds. Right? Yeah. So if you've understood this clearly, we'll move on and we'll calculate what the acceleration. Suppose you didn't get that. Go back through this video and write them down individually. It sometimes helps. Okay. Putting everything in the formula, you have final minus initial velocity by time. Final is 4, initial is 6, and time is 5. So that gives you minus 2 by 5. It's okay to put negative or positive symbols when we are calculating acceleration. Okay, let's move on. Acceleration is minus 0.4 meter per second square. Especially in quantities like acceleration, not just the unit, you have to remember to put the symbol also, because putting the negative and the positive sign will actually make a huge difference in your answer. Because if you remember, whenever we talk about positive and negative in acceleration, we're talking about whether we're calculating it in the same direction or the opposite direction, correct? Here the acceleration is negative, so I can take this as the bicycle slowing down in that 5 seconds. That's what it means. It slows down in that 5 seconds with an acceleration of 0.4 meter per second. That's why that minus is very important. If I don't put the minus, if it was plus, then it means that in that 5 seconds after he applied the brake, the bicycle actually accelerated to 0.4 meter per second, right? If you got that, let's conclude. In this case, acceleration is minus 0.4 meter per second square.